Belinda, Aggie, Veron, Elise, Polly, Eunice, Evan. Okay. Yeah, okay. Welcome to tonight's Facebook Live session, brought to you by Heuristics. So if you haven't already, here are our archives and page to download the notes. You can go to this 𝗪𝗵𝗶𝗶𝗶.com/blog. It will be on the first post with the link to download the notes. Okay? Yeah, Jennifer, I know you're Delvin. I know you're using your mom's phone. Jessica, I know that you are Jazel. Hello to Seth, Juliana, Rabia, Rashida. Yeah, Unicorn, I'm watching myself. May, Suislin, Iris, Edison. Okay? Yeah, I know. Okay, so a bit about myself. My name is Kevin Huang. I'm the curriculum specialist here at Heuristics. I've been working here since 2011, and I hope to grow more with the company because it gives me autonomy to explore several things that I'm interested in, such as this online learning and online teaching, online sharing. Okay? So that's just one of my little aspects that I'm involved in. I'm also involved in several other things, but I won't talk about them today. Okay? So anyway, these ideas on age differences are based off the Mastering Heuristics series that my boss and mentor, Mr. Sunny Tan, has written. He has written 5 books since 2009. And right now what I have with me, let me just show you, is the Unit Transfer Method, 2nd edition, which was written back in 2010. Now, the second edition was reprinted and published back in 2010. The first edition was printed back in 2009. Okay? So, what do all these books consist of? It consists of examples with a one-shot solution and also detailed step-by-step explanation on breaking down the thought process on how to go about solving these problems. Okay, so why is the thought process important? Because during the PSLE, there's bound to be some unfamiliar questions to differentiate or distinguish, distinguish between the A and A star students. So there's going to be some unfamiliar problems which you really need to define and break down the problems to understand it and use the appropriate heuristic to solve it. Okay, one such problem is, I should say 2 such problems. If you don't believe me, you can go and check it out. Oops. Last year's PSLE, there are 2 questions. I think it's paper 2, question 9, and paper 2, question 17. So these are the types of questions that you will see that are uncommon and hence unfamiliar to students. And based on that, we have to resort back to first principles thinking to break down the problems, analyze them, look for an appropriate heuristic to solve. That is why I also put so much emphasis on thought process and explaining that. So today, I'll be talking about one aspect of this. This will be on age difference. Okay, for age difference, this is a common problem that I see in the forums every day. A lot of parents are always asking how should this be done. Okay, so let me break this down for you first. Okay, let's get into the lesson proper. Now, on age problems, the first idea that you have to be able to observe. Okay, let me change to white mode real quick. Okay, prepare your eyes. It's going to hurt quite a bit. And you'll understand why I prefer to use black mode more often. Okay, hi 𝘂𝗶𝗶𝗶𝗀. Hello to 𝘂𝗶𝗶𝗶𝗀. Okay. So let's take a look at this. Let's say that A is 40 years old and B is 10 years old. The age difference between them was 30. Okay, 4 years ago means that both of them would have to go back in time by 4 years. So Ali is going to be 36 years old, Ben is going to be 6 years old. Their age difference is still going to be 30 years old. Okay, you can observe one thing. For age difference, assuming that both parties are still alive, okay, the age difference always remains unchanged. Okay, Delvin, stop spamming. The age difference between two parties will always remain unchanged. Now just imagine this. You can never be older than your parents. Okay, this is a fact. Unless you time travel or something. Assuming both of you are alive, you can never be older than your parents. Unless you discover some time traveling mechanic. Okay, that's not going to happen. The reason for this is that time flows in parallel for everyone. So you would always have the same numbers with the same signs. Okay, and your difference will remain unchanged. So how can you view this from a model perspective? Okay, instead of tabulation, those of you who are more familiar with models, okay, let's do it by models. So let's say two people are here, okay, and you add on the same number to both of them. Now, keep in mind that this is your difference. So if you are adding on the same number, you can either do it here and here, or what we prefer to do to make it more visually impactful is to put that same change over here, and then your difference will not move. Okay, if you are to look at it from if you are to take away a certain number, the same amount, this is your difference. Okay, if you remove off these two portions equally, you will see that the difference still doesn't change. Okay? Okay, unicorn, please stop. Please stop. Unicorn, please stop and focus. Okay, so anyway, okay, let's get into it. Okay, let's show you how this is done. Okay, the ratio of Sharon's age to her uncle's age is 3:7. Okay, let's allocate the units first. We can represent this with 3 blocks, and we can represent the uncle's age with 7 blocks. So in 6 years' time, that ratio is going to become 1:2. See, so this is the change. And this is your after result. This is your before. Okay? So we are to find Sharon's present age. Okay, so how is this done? Let's tabulate the information first. Okay, I think I can go back to black mode now. Yeah, this is a lot more comfortable on the eyes. And I can get to use the colorful colors. Okay, you got 𝘄𝗏, you got uncle. There's a before, there's a change, and there's an after. Okay? So let's input whatever we know first. 𝘄𝗏 here is 3, uncle here is 7. Okay, so in 6 years' time, both of them are going to age by 6 years. It's not possible for one of them to age and the other person doesn't age if they are both alive. Okay? That ratio becomes 1:2. Okay, so how do you know that this has to go to 𝘄𝗏? Because, like what I said, 𝘄𝗏 cannot, if the 𝘄𝗏 is younger than the uncle, there is no way that 𝘄𝗏 can be older than the uncle. Okay? So, once we've got that, we can either say that because we have the same numbers with the same signs, hence the difference remains unchanged, you can identify it from here. That's the first way of doing. Or you can reason out that the age difference between them will always remain unchanged. So we will extend out a difference column and compare them. So let's do that. Okay, 7 blocks minus 3 blocks over here gives you 4 blocks. 2 big blocks minus 1 block will give you 1 over here. So what's this all about? We say that these 4 small blocks has the same length as this 1 big block over here. So we want to make them the same. Multiply that by 4, we get 4, 8, and 4. Okay? Then, once we've done that, we want to compare from 3 units to 4 units. What was the change? Remember, the change in units is going to be 1 unit, which is 6. So once we've got that already, you want to find 𝘄𝗏's present age. That is the most updated unit. We want to find out these 3 blocks over here. So this will be 3 times 6 to give you 18. Okay? So the answer here is going to be 18. Yeah, okay, a lot of you got it. Sandhya, Ken, Catherine, Eunice, Sagi, Mradula, Jonas, Kelly. Yeah, you all got it. Unicorn, please stop. Okay, you all got it. So the tabulation is one easy way to figure out most of the problems. But of course, in certain cases, the tabulation alone cannot solve everything. Okay, I will be the first person to tell you that even though we have developed and fine-tuned this unit transfer method, it cannot solve everything. Now, let me be very upfront with you. Okay, because the way the whole curriculum has been designed is not going to be, it's not gameable. Let me just put it that way. So over here, at present, Sam is 4 times as old as his cousin, John. Now in 15 years' time, Sam's age will be 26 years, less than thrice of his cousin John's age. How old is Sam now? Okay, so let's break this down first. This is your before, this is your change, and this is your after. Okay? Well, there's a lot of mapping of names to remember. Zhenhui. Okay. Okay, so question 2's after looks a bit confusing. I understand that. Okay, let's break this down first. So let's try it by tabulation. Okay. Let's tabulate the information. Sam is 4 times as old as the cousin, John. So in 15 years time, both of their ages is going to age by 15 years. So you can see that over here you have a mix of blocks and numbers. Okay, to avoid confusion, let's just label them as units first. So this now becomes 4 units plus 15. This now becomes 1 unit plus 15. Okay? So we know Sam's age is going to be 4 units plus 15 in 15 years time. Then we want to break this down. We want to know what is 3 times of his cousin age. So right now, let's look at it this way. 1 unit and 15. Okay? So, okay, you all draw this first. I'll give you all 15 seconds to do it. Okay, so now once we got this ready, you got 3 times of this amount. So we draw out 3 of these boxes first and break it down like this. Now personally, I'm not a fan of extreme fast methods. Okay, it's interesting to know it, but I won't teach our students that way because I rather go through this process of breaking down everything. Not everyone is like A star or A student who can understand everything at first glance. So I'll break it down like this. Then this is 3 times of John's age, which means to say that we can combine them up, put all the units together, and put Sam's age over here. So for John, John's age, if we got to combine these units up together, we'll get 3 units here. And if we put all the numbers together, we'll get 45. Alright? Okay, stop spamming inside the chat, please. Focus on the lesson. Okay, I'll talk a bit more about that later on. Then, okay, so once we have defined 3 times of John's age, what are we going to do next? We want to draw out Sam's age over here. Sam's age is 26 years, less than thrice of his cousin's age. So if Sam's age is going to be less than this, it has to be shorter. Okay, so how short is it going to be? Now Sam is going to have 4 of these blocks first. 4 units and 15. So let's draw out the 4 units first and draw out the 15. His length is still going to be shorter than 3 times of John's age by 26. Okay, so once we have done this already, the next thing that we want to do is to compare between units with units, numbers with numbers. So once we've got this, this must be, this 1 unit here, you can see it clearly. It has to be 45 minus 15 minus 26. Okay, then this is going to give us 4. So ultimately, what do we need to find? We need to find how old is Sam now. So we have to be aware of what your table represents. This represents the present because they say that this is at the present moment and this is in the future. So Sam is going to be 4 units old now, which is 4 times 4. So this will give you 16. So your answer here is going to be 16 years old. Okay. Right. 𝘂𝗶𝗹𝗹'𝘀 Eunice Jaisal. Yep, you all got it. Okay, definitely we will take that into consideration on about teaching about spatial visualization, because we covered that, I think, like around the beginning of the year. Okay, so you can see that if you prefer, you could also do 3 times of 1 unit and 15. Okay, 3 times of that. If you know how to deal with it, you can do it directly. This would just be 3 units plus 45. You could also do it that way. Okay, this is more for P5 and P6. Okay, so it's about breaking down what those statements mean. Okay, very good. Let's move on to number 3. You're gonna learn coding as a subject. Yep. But coding is quite fun, to be honest with you. Okay, coding. Never mind. I'll talk more about that later on. Okay, so let's move on to number 3. This is also another, it's seemingly confusing question, but let's just break down all of the predicates first. Alright? And what they are trying to say. Now, Raymond's present age is 3/4 of his sister's age. 3 goes to Raymond, 4 goes to the sister. This was before anything happened. So his sister will be 32 years old in 8 years. So this is an after result. Okay, then when was Raymond's age? 2 years, less than 75% of the sister's age. Okay, over here, this is probably the part that we need to break down. Don't worry. Okay, if you keep on telling yourself this is confusing, this is so hard to do, your mind is going to set you up for that. Okay, and then you're really going to see that it's going to be very hard to do and it's going to be confusing because you're telling yourself that all the time. So in maths, keep calm and apply heuristics. Okay, now let's just break this down first. The sister will be 32 years old in 8 years. So cut to the chase. If you break down this grandmother story, the sister is 32 minus 8, 24 years old at present. Okay? If you need to label down what all these things are, do it. If it helps you to be more aware of what's going on, do it. Okay? Don't try to cut corners. Then over here, 75% can be changed into a fraction. This would represent 75 small blocks out of a total of 100. Then this can be changed into 3 out of 4. Okay? Do the decimal working. Okay, so now if the sister's present age is 24 and Raymond is 3/4 of his sister's present age, then this would have to be 18. Can you all see that? Okay, don't worry if you don't worry about it. Let's just break this down first. So this is the present. Okay, the sister is 24 years old and Raymond will be 18. Okay, so this is Raymond's present age. Am I going backwards? yeah, you need to find out when was it that this happened. So there was once upon a time that Raymond versus the sister. Whether this is the future or the present, whether this was the past or the future, you're not too sure. So let's look at this. This should be the past because this was represents the past tense. So Raymond's age is going to be 2 years less than 3/4 of the sister's age. So the sister's age can be broken down into 4 blocks, and you want to consider 3 of them. It's going to be 2 years less than this. Agree? So once upon a time, Raymond was this, had this bar over here. Okay, so it's worth noting that this block, these pink blocks, have a different length as compared to these blue blocks over here. Okay, so having defined all these problems already, what else can we do? Okay, look carefully for what you need to find. When was this? Okay, not their absolute age. So recall that because we are dealing with age difference over here, we are dealing with a problem in ages, the age difference is always going to remain unchanged at 6. So it goes to say that this portion from here to here has to be 6 as well. Which means to say that this 𝘂𝗶𝗹𝗶𝗀 block has to be 6 minus 2 to give you 4. Once upon a time. Okay, so what else do we know from here? We can find out the sister's age. The sister was 4 times 4 years old, 16 years old. Okay? When was Raymond's age? So over here, we want to find out Raymond's age in the past. If the sister was 16 years old, Raymond was 6 years less than her. So this would be 16. Let me write it here. 16 minus 6 to give you 10. So Raymond must be 10 years old. Okay. Okay. Yes. When was Raymond's age? This amount. Yes, it's 10. So this is how we can break it down with either models or tabulation. In certain cases, models, you'll find that models is actually easier to break down the problem. Okay? Like what I said, although we have refined and fine-tuned the unit transfer method very often, there are still certain exceptions that you'll find it quite difficult to solve with this. Okay, I think I'm the first one and the only one who's going to be very upfront with you on this. It can't solve everything. And that is why you need a combination of heuristics. Okay? So that's very good. Okay, let's move on to the next one. Now, Daniel's age is 9 years old. When he is as old as his uncle's present age, his uncle will be 55 years old. How old is his uncle? Okay, to deal with this, okay, let's just draw out the models and try to define and make sense of what's going on. Right. First things first. Now there's going to be a before and an after. Daniel's age is 9 years old. Please cancel out this one. This was before anything happened. One day he is going to grow to become as old as his uncle. So this is your after result. The uncle is going to be 55 years old. This is your after result as well. The uncle's present age is also your before. Okay, so let's try to define this first. Of course, there's an easier way to represent this, but let's just break this down from first principles. You got Daniel, you got the uncle. Okay, so Daniel is now what? 9 years old. The uncle is of a certain age. Okay, very good. A lot of you got it already. Uncle has left the chat. Okay, I'll give you all another 10 seconds to draw this out. Okay, so after that, what's going to happen? Oh yeah, forgot one more thing. Let's label down 9 years old first. After that, if you compare between Daniel and the uncle, okay, let's draw down these lines, extend down these lines as we've covered in the previous modeling part. These lengths represent the quantity. The longer it is, naturally the more it will be. So over here, Daniel is going to become as old as his uncle. So he has been uncled. Okay, he becomes an uncle also. Then the uncle is going to grow by the same number of years. Okay? So this age difference between them, okay, the uncle is going to become 55 years old. Okay, and this age difference between them is always going to be the same. Correct? So if this is the case, if he was to grow to become as old as his uncle, then can you see that this also has to be 1 unit here? Whatever that may be. So this is 9 and this is also 9. Okay, once we are able to do this, once we are able to represent this, we can now focus on the uncle over here. Okay, this will just be 55 minus 9. We can say that 2 units will have a value of 55 minus 9, 46. 46 divided by 2 to give you 23. So we want to find out how old is his uncle. So we are not talking about the future, we are talking about the present. This is your future. And the uncle is going to be 9 plus 23 to give you 32. And hence your answer is going to be 32 years old. Okay, a lot of you got it before I gave you the answer. That's very good. Okay, don't say all the 不吉利话 over here, please. Yep, Joanne, Eunice, Daphne, 悠悠自在, Kelly, Sandhya, Ernest, Sanvi, 𝘂𝗿𝗲𝗍, Gayatri. Yep, you all got it. Jonas got it too. Sheila also got it. Okay, so you can see that modeling in some ways is also superior to tabulation. Okay? Right. Hope you all had an enjoyable time. So how would you know which is the appropriate one to use? For this, we have a wide range of Mastering Heuristics series books written by my boss and mentor, Mr. Sunny Tan. So here we have the unit transfer method, which explains in detail how to go about tabulating the information, organizing them, and solving the problem. Spatial visualization for problems on area and perimeter. Then the model approach to problem solving. We just did a mini series on this like for 4 weeks. You can go and check those videos out in our blog post. The unit transfer method for P4 and also the unit transfer method for problems involving speed and rate. So we have a wide selection of books. You can zoom in on your target weakness, okay, and you can access it through this link over here. Okay, so what do all these come with? Okay, so you're wondering, if I order online, it's going to take SingPost a while to send it over. So you may also be wondering if your package will be sent safely or not. Okay, first we will be sending it by registered mail. You'll be getting the hard copy book through registered mail. So chances are this will be very safe. SingPost registered mail. Second, this ebook will be sent to you so that you can view it first. Okay, then third of all, we'll be sending you the web videos that covers the guided examples, and fourth, we will send you the mobile apps as well. So how does the mobile apps look like? Let me just show it to you first. Okay, so this is on the tablet. Okay. And let's just pick a random example. First, they will cover the guided examples in an interactive format. So you can see the reflection of my webcam over there. Okay. Anyway, it will cover the one-shot solution. And second of all, it will cover the explanation in an interactive manner. Okay, so it goes progressively to explain the thought process. Because for certain kids, they may find that a wall of text is intimidating. So what we are doing right now is we are trying to adapt and adjust to everyone's learning capabilities. Okay, it will take a while to map out everything to cater to everyone's needs, but we are progressively doing that. Okay? Okay, for those of you who are done with this, you can leave us. If you have questions for me, I will take them now.